So it started on 14th of May and we ended on like end of June. So it took like almost 1.5 months for haloalkane. It's not because it is a lengthy chapter. है ना, उससे बहुत ज़्यादा मार्क्स से सवाल नहीं आते, but because we are introducing many new mechanisms, है ना, we are introducing Markovnikov's rule, anti-Markovnikov's rule, then we are introducing Setzeff rule, then we are introducing new allylic, benzylic, all of these things, and we are getting introduced to the world of organic chemistry once again in the 12th standard. Okay, that is why it took a long time. Compare it with the number of lectures for phenol, a bit less, and even lesser number of lectures will be required for aldehyde, ketones, and carboxylic acid, even though it is a larger chapter. Why? Because many of the reactions that we are going to do in this particular chapter is already done. Okay, you will see that. Now, in today's class, we are going to write first of all a bit of nomenclature. We are going to revise a bit of nomenclature, and especially the common names. Okay, so write the chapter's name first of all: aldehyde, ketones, and carboxylic acid. Aldehyde, ketones, and carboxylic acid. Now, in this particular chapter, we are going to learn about a few compounds. First one is obviously aldehyde, which has a structure like this. And or you can write it as CHO. This is aldehyde. We call it al. The suffix is al. Then we have ketone. So this will be CO and some bond there. This is ketone. For this we use the suffix on. Then carboxylic acid. No, I'm writing just Ca, carboxylic acid. For which this we use the suffix oic acid. Now you are also going to look at some esters here, but we are not going to do method of preparation of ester and all. So this is ester, which is known as COOR. And this is ester. Suffix is O8. Then we are going to look at acid anhydride also. Okay. Carbon, double bond O, oxygen, bonded to again carbon double bond O, like this. Okay, there will be some other groups here. All of you got this? So this is what acid anhydride. How do we show this? We show it like this. Whatever group is present here, CO, okay, hold twice, and ठीक है, but you are going to look at it like this one. Majorly आप इसी तरह देखिएगा. अगर यहाँ पे R लगा हुआ है, यहाँ पे R लगा हुआ है, then you will write it as R CO hold twice bonded to O. This is acid anhydride. Okay, you don't need to write the name of this particular compound. Okay. Is everyone done writing this? Yes or no, please tell me. Done, na? Can I move on? See next. Right, nomenclature. First of all, common name. Okay, common name. Now, please see, there is a concept which is known as acid. Okay, we are going to learn about two different concepts: concept of acid and concept of form. क्या बोला हमने? Acid, ACET, not acid, it is acid. ACET. Okay, what is ACET? It is carbon with double bond O that is attached to a CH3 group. Got this, guys? Yes, please tell me. याद रहेगा हाँ या ना?
Yes.
CH3 attached with carbon, and there is some group attached on this particular carbon atom. Now, from acid, you can make many things. Okay, please see here, don't write anything now. If you want to make acid aldehyde, let us suppose you are making acid and you want to make aldehyde from it, aldehyde. Okay, then how are you going to write the structure of acetaldehyde? What should I add to this carbon atom to make it aldehyde? Tell me, guys. This is acid.
H.
What should I add to H? All of you got this? Yes or no? Please tell me. Anji. Got it now? Similarly, tell me, what should I add to this particular carbon atom to make it a ketone? That will be acetone. Acetone is ketone. So what should I add to this particular carbon atom?
CH3.
CH3 I will add, and it will become ketone. And if I want to make it acetic acid, so that means I want to make it carboxylic acid. So what should I add to CH3 C double bond O? To make it a carboxylic acid, what should I add to carbon? This particular carbonyl, carbon. What happened, guys? No one. Hafsa, Aisha, Alia. Saad.
OH.
OH, no. Okay, so this is what? Yes, Alia. This is acetaldehyde, acetone, and acetic acid. All of you understood the concept of acid? Not acid. Acet, ACET. Got it, guys? Just want to listen me.
Yes, sir.
Now, there is another concept that is known as form. Write this down. Then we will look at form, FORM. Got it, guys? Yes or no? All of you wrote this down? All of you wrote this down? Yes or no? Please tell me. This we have added hydrogen. Here we added CH3, and here we added OH. Okay, remember this. Sorry. Anyone still writing? Please let me know. Concept of form, FORM. So form is hydrogen that is attached with carbonyl carbon, and there will be some group attached here. Okay. So I can, since it is having hydrogen here, I cannot make a ketone. So, but I can make a aldehyde. So form aldehyde. Formaldehyde means H. What should I add to this carbon atom to make it a aldehyde? Another hydrogen. Similarly, formic acid. Formic acid. Formic acid is H, C double bond O as it is. What should I add to carbonyl carbon to make it a acid? It will be OH. Write this down. Okay, so these are very much used. Formaldehyde, acetaldehyde, these are used intensively. These are going to be used, okay, many times. There are a few more words. For example, if I have 1, 2, 3, 4 carbon atoms, and this fourth carbon atom is CHO, this is commonly known as butyraldehyde. 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 And if I have 4 carbon atoms and COOH, then it is known as butyric acid. Butyric acid. Similarly, if I have 3 carbon atoms and CHO, this is known as propion aldehyde. Propion aldehyde. Propion aldehyde. And if I have oleic acid, so this will be propionic acid. All of you got it, guys? Yes or no? Please tell me. Write this down.
Done, sir.
All of you done writing? Done? Right, next. Please see. Use of alpha, beta, and gamma for substituent. Use of alpha, beta, and gamma for what? For the substituent. So all of you know what is alpha carbon, beta carbon, and all of these things? Yes or no? Please tell me.
Yes, sir.
Okay, so for example, if you have something, let us suppose CHO, and here I have a Br group attached. Okay, so you can write IUPAC name. I completely know it, but sometimes this particular compound may be referred as, for example, this is my functional group. So this is my alpha carbon, this is my beta carbon, and this is my gamma carbon. Okay, this will be gamma carbon. Now here we are having substituent bromo in the beta carbon. So it will be beta bromo. And this is what butyraldehyde. You can see butyraldehyde. Similarly, if you have, let us suppose you have COOH and you have a CS3 group here, then it will be written as, this is alpha, so it will be alpha methyl 1, 2, 3. So propionic acid, propionic acid. Got it? Yes or no? Please tell me. हाँ बताएं.
Yes, sir.
Okay. This is the use of alpha, beta, and gamma. Now, another important thing is naming ketones by the alkyl groups. So here, let us suppose you have a simple three carbon atoms and you have a carbonyl carbon here. Okay. Now we call this particular compound, this is methyl, this is also methyl. So what are the two groups that we have? Methyl and methyl. That means dimethyl. And this is ketone. So dimethyl ketone. And if you had something like this, so here you had what? This is ethyl. This is also ethyl. This will be diethyl ketone. But if you have, let us suppose something like this, C double bond O, then here we have methyl and here we have ethyl. So it will be ethyl methyl ketone. E will be coming first because E is E precedes M in the alphabetical order. Okay, so ethyl methyl ketone. Okay. Let us suppose you have di tertiary butyl ketone. So how are you going to name it? Please see. Tertiary butyl is one carbon atom which is bonded to three other carbon atoms. So this will be bonded to ketone. And here also I will have the same thing. CH3, 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 CH3. So this fragment is 4 carbon atom and the point of attachment is tertiary. So it is what? Tertiary butyl. This is also tertiary butyl. So we have 2 tertiary butyl. That means di-third butyl ketone. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay. Can I move on? आगे बढ़े?
Yes, sir.
See next. There are a few common names that you have to remember. What are those common names? That is related to what? That is related to the benzene wala compounds. Okay. So for example, if you have CHO, so this will be benzaldehyde. Okay, if you have carbon double bond O and then CH3. Now this part is, tell me what is this called? CH3 C double bond O. What is this called? You guys forgot. First topic. CH3 C double bond O is called what? Tell me guys. Acid. Yeah, correct. ACET. And this is a phenyl ring attached, making a ketone. That is why it is known as acetophenone. All of you got this? Yes or no? Please tell me. Okay. Now there is another thing which is known as PC. So this carbon is what? Benzyl carbon. And if you attach a C double bond O here, this will become benzo. And if you attach a phenyl group here, this will become benzophenone. All of you got this? Yes or no? Please tell me. Write this down. Let me know once you're done. All of you done? No one is writing, no? Chali. Now, there in IUPAC naming also, there are a few things that we are going to revisit. In IUPAC naming also, there are a few things that we are going to revisit. So in IUPAC naming, what we are going to revisit, for example, if you have something like this, or rather, let us suppose you have something like this. Here also you have CHO. Okay. Now, when you have something like this, then what do we write? We write it like this. Please see. We will say that we have propane and we have 3 carbaldehyde group. This will be now known as carbaldehyde. So in this particular specific case, we are going to write it like this: propane, 1,2,3 tricarbonaldehyde. Okay, because we want to give all of this CHO the same importance. Okay, so I am not referring one of them as formyl or one of them as oxo. Rather, I am referring all of them as carbonaldehyde. Similar is the case if you have something like this. Okay. Now, in this case, if I take this as functional group, then I will only have one particular atom. So I will rather write it as cyclopentane carbonaldehyde. Is everyone done? Is everyone done? Yes or no? Done? Okay. Let us just do one question that is based upon ketone and aldehyde. And then we are going to, for example, please write a question. 1, 2, 3, 4, 5 carbon atoms. Here I have double bond O. Here I have, let us suppose, double bond carbon atoms. And here I have CHO. Okay. So functional group will be equal to obviously aldehyde, because aldehyde has more preference. So it will be Al. And after that, unsaturation will be equal to, there is a double bond. That means En. Then I will move on to parent. So parent, I will start with the functional group carbon atom. So 1, 2, 3, 4, and 5. So this will be 5 carbon atom, which is pent. Now we are going to look at the subsequent. Yeah, we have a subsequent that is this O. So which will be oxy or oxo, my word. Oxo, right? Now I will write the numbers. So 4 oxo pent, and the En is in the second carbon atom, Al is in the first carbon atom. So it will be 4 oxo pent 2 in 1 al. Write this down. Let me know once you're done. Also, for example, if you have something like this, CHO and NO2 here. So I will write it as M nitro benzaldehyde. We have C double bond O. And let us suppose you have CS3 here. And here you have PR. Rather, wait a second. Let me put it in the para position. It will be 4 no, rather it will be P bromo. Acetophenone. Write this down. Let me know once you're done. All of it done, yes or no, please tell me. Anyone still writing, please let me know. Okay, no one is writing. Fine. Now, we are going to look at the method of preparation of aldehyde and ketones. So we are going to look at the 3 different classes. Okay, don't write anything, please listen. When we talk about MOP, I will first of all look at MOP of aldehyde and ketones, both of them. Then I will look at MOP of aldehydes only. Then I will look at MOP of ketones only. Okay, so this is going to take a bit of time. First of all, please write the topic MOP of aldehyde and ketones. Number one. Aldehydes and ketones. In this, you will write number one from alcohol. From alcohols. You have seen in the last lecture, I mean, not last lecture, but in the last chapter also, from alcohols, we can make it by oxidation. A part is by oxidation. In the chemical properties of alcohol, we saw the oxidation of alcohol, and we saw that if I'm using 1 degree alcohol, that means if I'm using RCH2OH, any oxidizing agent, what I'm going to get? I'm going to get RCHO. Similarly, if I use a 2 degree alcohol, that means R, CH bonded to OH with some other R dash group attached here, I will be getting R, carbon doubly bonded with O, and then R dash. So here I will get aldehyde, and here I will get ketones. That means alcohol can be used for the formation of aldehyde and ketones both. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay, so now I will write some reaction. आप लोग आंसर कीजिएगा, है ना? Write a question. Fill in the blanks करते. Fill in the blanks करते. Write this down. Let me know once you're done. Send your answer on my WhatsApp, okay? In the first three, you have to give me the product, and in the fourth and fifth, you have to give me the reagent. I have not done any reagent in this class, okay? But we have done reagents in the alcohol phenol chapter. So flip some pages. Look, how do we go from alcohol to aldehyde, and how do we go alcohol to ketone? And what are the reagents that we can use? Take 3 more minutes and send the answer on my WhatsApp. Send your answers on my WhatsApp. What happened? You guys are able to do this, yes or no? Tell me. Alia, Aisha, Hafsa, Mariam Khatun, Mariam Parker. You remember these reagents, yes or no? PDC, PCC, CRO3 from the last chapter, alcohol phenols ethers. Guys, answer at least. Yes, no, something. Yes, Mariam Khatun, Mariam Parker, Hafsa, Aisha. Hafsa, you remember this? Yes or no? Hafsa, do you remember this? No.
Sir, I'm trying.
No, you have to flip some pages and you have to get the answers. No time. You have to get
Okay,
the
sir.
answers. Okay. Some answers, I guess. The answer. Mariam Parker has sent. Ali has also sent. Parker, first one is correct. Second one is wrong. Third one you have not done. Fourth one fine. Fifth one is fine. Retry the second one, Parker. Two chats. Hafsa's WhatsApp is the WhatsApp will be fine. I'll look at the answers. Hafsa, wait a second. Alia, first one correct, second one correct, third one correct, fourth one. Yeah, very good, Alia. Hafsa, you have sent it here. Mariam Khatun, you forgot everything or what? First correct, second correct. Second one, yes, very good. Correct, very good. Third is also correct. First one is wrong. Second one, Hafsa, your answers. Okay, first one is wrong. Third one is wrong. That's it. PCC. हाँ ठीक है. First and then third is wrong. Please see what is wrong there. Okay. Parker correct. Fifth one. Fourth one correct. Third one correct. Second one is wrong. Please see the second one. First one is correct. I think Alia, your second one is also wrong. Alia, look at the second one. It's wrong. Please see why it is wrong. Again, it is wrong. Mariam Parker, the second one is still wrong. Aisha, first one correct, second one wrong, third one correct. Fourth one is also wrong. Oh, I can understand now. People are doing some mistake. That mistake is counting the number of carbon atoms. ये हमने भी मेरे ही से mistake हो गया था ये. My bad. ये हम ही से mistake हो गया. This will be CHO here because of 3 carbon atoms. Okay. So fourth one was my mistake. It will be PCC here. Number of carbon atoms I messed up with that. And you guys also messed up with the number of carbon atoms in some of the questions. Here you'll have double bond O. Here we have only 2 carbon atoms. So it will be CHO like this. Okay. Or rather, better way of writing this will be CH3CHO. PDC is what? It is a weak oxidizing agent. Others are fine. And here also PCC. Because we are going from aldehyde to ketone. I don't know how I did that mistake. My bad. Is everyone done? Yes or no? Please tell me. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Okay, just a second. Correct the mistakes, those who have done it. Now, after this, write next. Note. Usage of SOA. What is SOA? Who will tell me? Hafsa, what is SOA? Hafsa, what is SOA?
Strong oxidizing agent.
Very good. Usage of strong oxidizing agent on 1 degree alcohol leads to formation of carboxylic acid. Okay, but if they give you something like this, you have 2 degree carbon, alcohol, and they are giving you oxidizing agent which is strong, K2Cr2O7, or they give you or KMNO4. Okay, so in that case, and they have not written high heat or high temperature, something like that, then what you do, you will just make a ketone. Okay, but 2 degree alcohol, it will give you ketone. If they give you like this, then you are not going to worry about the strong oxidizing agent for ketones. You are directly going to write about, for 2 degree alcohol, you are not going to worry about the strong oxidizing agents. Okay, even though it is not preferred if they ask you like this, na, OH, and what reagent should be used to make ketone, then that reagent should be using PCC or CrO3. PCC you can use PDC, or you can use CrO3. Never write in the name of reagent K2Cr27 because it is not a preferred method of preparation, because it will give you some carbon-carbon. There will be some carbon-carbon bond breaking also. Okay. So if they give you K2Cr27, you will write the answer as ketone. But when they have given you ketone, you will not write K2Cr27. I hope that makes sense. Yes or no? Please tell me. Makes sense, guys? Yes or no?
Yes, sir.
Here we can use PCC or PDC or CrO3. Moving on, we have also seen another method of preparation from alcohol, that is catalytic dehydrogenation. Catalytic dehydrogenation. Okay, please write 1 degree alcohol, RCH2OH, in the presence of copper and heat, 573 Kelvin, heat we will write, gives you RCHO plus H2. Similarly, 2 degree alcohol, RCOH in the hydrogen, and here you will have R dash. Copper in the presence of heat, it gives you R, C double bond O, and R dash plus H2. We have already seen this reaction also. So write a note here. 3 degree alcohols gives alkene. Now we have seen this reaction. No need to write it once again. Another point is that instead of copper, we can use Ag2. And we can also use silver.
Sir, sir, can you please read the second point?
Oh, sorry. That is instead. INSTEAD. Instead of copper, we can use Ag2. Just a second.
Done, sir.
Done. Right, next. Can you see we are seeing similar reactions? Yes or no? Similar or same reactions only? Now we are done with alcohols. Now we are going to use another substrate, that is hydrocarbon. From hydrocarbons. And in hydrocarbons, we will first start with alkynes. And the reaction is hydration of alkyne. What is hydration? Hydration means adding water. Hydration of alkynes. Now for this, you will write a statement. Please write aldehyde and ketones can be prepared by hydration of alkynes, hydration of alkynes in the presence of dilute H2SO4, and HgSO4 as catalyst. Okay, how the reaction happened, you may not remember this reaction, but this reaction was present in the hydrocarbons chapter that was on 11th standard. Okay, please write next point. Water adds to the triple bond making an unstable enol. I will make you understand what is enol. Making an unstable enol, which rearranges to aldehyde or ketone. Okay, so see, what is the reaction here? Please see here. You have R bonded to carbon, triply bonded to carbon atom, and here let us suppose we are having a hydrogen. Yes, we are having a hydrogen. So I will add H2O. Now this carbon atom, it will get OH, and this carbon atom will get the hydrogen from the water. Okay, so in the presence of HgSO4, so I will write HgSO4 here, HgSO4, and I will get R, which is bonded to carbon atom, further bonded to OH, and then it is doubly bonded to now, because triple bond will be converted to double bond because there is an addition reaction, and this carbon atom is having two hydrogens, one hydrogen here and the other hydrogen is here. Okay, now please see what is happening in this particular part this here. So here we have carbon atom, here we have the R group, here we have the oxygen atom, and here we'll have the hydrogen atom like this. Double bond carbon atom. The two hydrogens are here and here. Now, please see very carefully. This hydrogen atom, which is bonded to oxygen, it will be highly delta positive because it is attached with electronegative element, which is oxygen atom. And here only we are having a pi bond electron cloud. If you remember pi bond is made by lateral overlap like this, and when they overlap, they form like this. This is a pi bond. So you are having electron density here and here. So high electron density near a hydrogen atom, and hydrogen atom is highly delta positive. So what happens actually, that this particular bond, it attacks on the hydrogen atom, and there is an equilibrium between these two compounds, and we'll get carbon bonded to R, doubly bonded to oxygen atom. Then it is what? Then it is singly bonded to carbon, and this carbon atom will get the three hydrogens. All of you got this? Yes or no? Please tell me. All of you got this? Anji, बताएं.
Sir, can you explain again?
Again, see here. The important point to note down is this OH, right? This OH will be attacked by the electron-rich pi bond, and when this attacks here on the electron-rich pi bond, this hydrogen atom actually it breaks because it is getting electron. So it no longer needs this particular bond. It will give this electron to the oxygen atom, making here double bond, and then this carbon atom will get the hydrogen. This carbon, see, this carbon is breaking a bond. This carbon is also breaking a bond. This carbon is getting the 4 bonds again by making a double bond O. This carbon is making 4 bonds by getting a new hydrogen atom. Okay, so this is known as, this carbon, it is having a double bond as well as OH. So double bond, so that is why ene. OH, that is why enol. Okay, so this is known as enol form. This is known as keto form. So obviously, keto form is more stable here because we don't have any electron poor hydrogen atom in this case. Okay, so ketone form is more stable, and it is known as tautomerism. So tautomerism will happen here. Tautomerism, and we'll get R. This carbon atom will get double bond O, and this carbon atom will get CH3. All of you got this? Yes or no, please tell me. Okay, so you can write this part also. This is tautomerism. Is everyone done? Let me know once you're done. इसको फिर थोड़ा सा डिटेल में देख लेंगे. See, there are few cases that we can have, है ना? We have carbon, triple bond carbon. Both of these can be hydrogens. That is one case. Carbon, triple bond carbon. Both of these can be R. Carbon, triple bond carbon. One of this can be hydrogen and the other will be R. Okay, so we'll look at 3 different cases, and this topic will be done. After that, we'll write a conclusion also. Okay. All of you done? Anyone writing? Yes or no, please tell me. Anyone still writing?
Yes, sir.
Any? Okay, please write them. Right here, addition of H2O occurs via Markovnikov's rule. Meaning, OH attaches on what I will say, OH attaches on which carbon atom? The carbon atom which is having तो छोड़ दीजिए. I mean, बहुत ज्यादा इससे फर्क पड़ने वाला नहीं है. ठीक है, लिख लीजिए फिर. On more substituted or rather on that carbon which has less number of hydrogen. So we already know what is Markovnikov's rule, huh? OH attaches on that carbon atom which is having less number of hydrogen. Is everyone done? Anyone still writing? Anyone still writing? No. Okay, so write next. So first of all, we'll look at H. अच्छा, एक कंक्लूजन हम यहाँ से ये कर सकते हैं. R C triple bond C H in the presence of H2O and HgSO4. What I will get, where the R group is attached, that will get the C double bond O, and you will get this one is going to get CS3. This much I can conclude. Yes or no, please tell me. Here we are adding OH. So wherever we are adding OH, that is getting converted to double bond O. Yes or no? Correct, guys? Hi, Anna. Tell me. Okay, Podo, hi. Can I write it directly? Yes or no? This carbon atom, here one carbon and 2 carbon atom, right? So first carbon atom is getting OH. Why? Because it is having less number of hydrogen. It is not having any hydrogen. Got it, guys? Yes or no? Hydrogen, carbon, triple bond carbon, and hydrogen. In the presence of H2O and HgSO4, what will happen? So how many carbons? 2 carbon atoms. Which will get the OH, 1 or 2? Which carbon atom will get the OH, 1 or 2?
Any of them.
Any of them, because they're having same number of hydrogens. Okay. So just to, I mean, be consistent, we can write HOH like this. So this carbon atom is getting OH. So this will become what? CHO. This will be having hydrogen, carbon, double bond O. And this carbon atom will get CS3. All of you got this? Yes or no? Please tell me. Hanji bataye. No problem, right? Tell me, guys.
Yes, sir.
No problem now. Can I move on? See here, next one, CS3 bonded to carbon, triply bonded to carbon and hydrogen. Now H2O, HgSO4. Here we have 1, 2, and 3. Tell me which carbon atom. See, here only 2 and 3 carbons are reactive. This first carbon doesn't matter even. Okay. So 1 and 2, you identify the triply bonded carbon atoms. Which one will get OH? Which one will get OH? Which one will get OH? Tell me, guys.
2.
2 or 1?
1.
1, right? Less number of hydrogen. No. First one will get hydrogen. Sorry, first one, sorry, my bad. First one will get OH. So this will get OH and this one will get hydrogen. So which one is getting OH is going to get converted to C double bond. We have CS3 as it is, bonded to carbon, C double bond O, and the other one will become CS3. Can you guys see a pattern? Yes or no? Please tell me, guys. Mariam Khatun, Aisha, Hafsa,
Yes.
can you guys see a
Yes.
yes, now? Okay. Now let us suppose if you have CS3, carbon, triple bond carbon, and then CS3 once again. Now in this case, H2O and HgSO4, 1 or 2, which one will get?
Any of them.
Anyone. So what you will write, you will just make 4 carbon atoms and 1 or 2 किसी में भी double bond लगा दीजिए. That's it. Got it, guys? Yes, no, please tell me.
Yes, sir.
Okay. Now let us suppose if you have something like this. CS3, CH2, carbon triple bond, carbon, and CS3, the presence of H2O and HgSO4. Now here you can some of the reaction will be happening like this. HOH. This carbon atom is getting oxygen. This is getting hydrogen. Some of them will be happening like this. Right? Both of them are not same. Both of these will be happening. So I will get 2 different products. In first product, I will have 1, 2, 3, 4, 5 carbon atoms. And we have in this, okay, so I will have double bond O here. थोड़ा आपको समझने में आसानी हो जाएगी. ठीक है. Let us suppose this is blue. Right. So in the blue case, I will get 2, 3, 4, 5. Here I will get the double bond. Got it, guys? Yes or no? Please tell me. Any difficulty?
Yes.
का आगे बढ़े. चलिए एक सवाल आपको करके बता दीजिए. सर चीटिंग करते हैं. सर आप चीटिंग करते हैं. हम लोग को आसान आसान पढ़ा के हार्ड वाला पूछते हैं. थोड़ा दिमाग तो लगेगा आपको. ठीक है, चलिए कोई ज्यादा हार्ड नहीं है ना. यू जस्ट आइडेंटिफाई द कार्बन व्हिच इज हैविंग, oh my god, wait a second, blunder I did, CS3, this will be CH only. Okay, so identify the carbon atom that is having less number of hydrogen, that will get the double bond. That's it. Okay, so you can directly make the compound. Again, I would ask you guys, if you are not able to do this problem, try to understand these. है ना? Write 1 carbon, 2 carbon. Okay, the carbon which is having less hydrogen is getting the double bond. है ना? Try to understand it that way. Very good, Mariam Parker. Mariam Parker, it's fine, right? Not very tough. Yes or no, Parker?
Yes, sir.
Yeah. Guys, Parker, do you have a like schedule? Like, how do you study? You have to send the answer, Hafsa. You have to do this. For the last one, you have to do this.
No,
Market,
sir.
tell me.
The question before that.
You can't see these two products.
No, sir. I asked like why there is two products.
So see, the OH, why there is, you wanted to ask. So why there is two products? See, slowly start. We will start. Huh? First of all, tell me, are both the carbon atoms same here? Triply bonded carbon atoms 1 and 2. Are they same?
Yes, sir.
They are same. How they are same? Tell me. Because they don't have any hydrogen, right?
Yes, sir.
But the first carbon atom, it is bonded to ethyl, and the second carbon atom is bonded to
Methyl.
second methyl. So they are different, huh? Yes or no?
Yes, sir.
But OH does not know that, right? OH does not. OH just sees that whichever is having less hydrogen, so it will attach to both the carbon atoms. Right? It will attach to both the carbon atoms like this. HOH. It will attack in this way also, and it is going to attack in this way also. So it is attaching on both the ways. So we are writing both the products. In the previous cases, if you see, then why not in the previous case, please see it. In this case, if it attacks on the first or the second carbon atom, if it attached on the second carbon atom, I would have got something product which is this. If you name the product, this is also 1, 2, 3, 4. This is also 1, 2, 3, 4. This is also butanone. Both of them are butanone. Butane 2-1, rather it would be. This will be butane 2-1, both of them. But in this case, it is pentane 3-1, and this is pentane 2-1. So we are getting different products. Got it? That is why I showed both the products individually.
Okay, sir. Thank you.
Okay. Fine. Mariam Khatun, very good. Sahi hai. Yes. Aisha, very good. Correct. Okay, so look at this one. 1 and 2. Which one will get OH? Hafsa, tell me. 1 or 2, which one will get OH?
2.
Why 2? Which carbon atom gets the OH with less hydrogen? No. नहीं, अभी भी नहीं आया. Hafsa. OH attaches to which carbon? With more hydrogen or less hydrogen?
Less hydrogen, sir.
So which is having less hydrogen, 1 or 2?
1, sir.
So it will attach to 1, right? And the carbon to which OH attached, that only becomes double bond O, right? OH becomes double bond O. So this will be your product. This will be CH3 now. Please understand, Hafsa, okay? Say these things. Look here, 1 and 2. 1 is having 0 hydrogen. This is having 1 hydrogen, okay? Say these things and then only write. Is everyone done? Yes or no? Please tell me. Is everyone done? After this, you will write. B part by ozonolysis of alkenes. By ozonolysis of alkenes. Okay, please write. This is also a reaction that is that you guys have learned in the 11th standard. Okay, right? Alkenes react with ozone to form. Ozonide, which on subsequent cleavage with Zn with zinc dust कर लीजिए and H2O gives corresponding aldehydes and ketones. So we will take alkenes. Alkenes, they have carbon, double bond carbon, and there will be some groups attached here and here. I will first of all react this with O3, ozone. This will form home. What is home? That is ozonide. And these two groups as it is. The two groups which was attached to carbon atom, they are as it is. When you further react this with zinc and H2O, then there is a cleavage. This carbon gets one oxygen, this carbon also gets one oxygen. And this carbon, whatever bond it has, it is having that bond, double bond O. And this carbon atom that was having anything else that was there, and you will get double bond O like this. Okay. Now you can also write that. You can directly write the product. So we have double bond here. You break this double bond. So you will be getting what? Carbon, something here, and double bond O. This is for the first carbon atom, right? For the second carbon atom, you have double bond carbon that you break, and this double bond will get double bond. All of you got this? Yes or no? Please tell me how to directly write the product. You will cut it like this. Whatever group is attached on the first and second carbon atom, they will be attached as it is. Okay. Don't worry, we'll look at the exam. Done, guys? Can I move on? Can you look at the examples now? Chali, please see. Number one, simplest. H2 carbon double bond, CH2. First of all, we will add ozone, O3. Second step is zinc in the presence of water. ZnH2. You will break this. So we will got H2 carbon with double bond O plus oxygen double bond CH2. Aya no? Tell me, guys, you got this? Yes or no? We'll get this only now when we are going to break it. Alia, Aisha, Hafsa, Mariam, Fatun, and Parker. Got it? Yes or no?
Yes.
Yes, sir.
Try this one. Try this one. Send the answer on my WhatsApp. Take 1 minute. If you are not able to, do it, then you will answer some of my questions. Okay. Is everyone done? Yes or no? Please tell me. Can the answer once you're done? How many of you are confused? Please let me know. Alia, you're able to do yes or no?
Yes, sir. Just tell me.
Whoever is confused, raise your hand. Please let me know quickly. Whoever is confused. No one is confused. That's also sent. Mariam Parker, Anji. Say very good. Aisha. Yes, very good. And Alia. Yeah, very good. Mariam Patoon. Wait a second. Patoon. मरियम खातून, जब आपने इसको ऐसे ब्रेक कर दिया, यहाँ पे क्या बचा? CH2 है ना, और तो कुछ नहीं बचा है ना, डबल बॉन्ड O, दैट्स इट। या कुछ और लिखेंगे? कुछ और होगा? हाँ जी, कुछ और होगा क्या? नहीं ना? हाँ जी मरियम, कुछ और तो नहीं बचा ना? बोलो भाई। ठीक है, तो बस इतना ही लिखना था। और यहाँ पे आपने जब किया तो ऑक्सीजन डबल बॉन्ड CH3। ठीक है, ऑल ऑफ यू गॉट दिस गाइस? सुनो, ठीक है। नाउ प्लीज सी व्हाट इज दिस H2CHO। ये सारी चीजें क्या है, ये ध्यान दे दीजिए जरा। H2CHO is nothing. You are having carbon double bond O, and this carbon is having 2 hydrogens. So this is formaldehyde. Can you see that? This is formaldehyde. Hi Anna. So both of these are what? Formaldehyde. And what about this one? It is 2 carbon atoms. So 2 carbon atoms, CH3. This one is nothing. It is CH3CHO. And this is same thing. Can all of you see that? Yes or no? Please tell me. I hope you don't have any confusion, at least in the namings here, right? Hafsa, your answer is also correct, I think. CH2 double bond or CH. But you should also understand this is nothing new. This is HCHO. And this is CH3CHO. आना बोल देंगे, थोड़ा हमको इत्मीनान हो जाएगा। मरियम खातून, हफ्सा, yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Now please see. Let us suppose we have something like this. Now, I am moving towards the bonding structure. Okay, I'm moving towards the bonding structure. Please see. If you have something like this, okay, and you break it. O3. Second step, ZnH2O. Here you will get 1, 2 carbon atoms. Here also 1 and 2 carbon atoms. So you will just write CH3CH. CH3 1 carbon atom, second carbon is CH plus CH3CH. Got it? Yes or no? Please tell me. No confusion in the third one?
Yes, sir.
No confusion. Please let me know if you have any confusion. Aisha, Hafsa, Mariam, Khatun. Let me know if you have any confusion. No, okay, fine. Now, let us suppose if you have something like this. And we have a CH3 here also. And this is CH3. Now when you are going to break it, then you have 1, 2, 3 carbon atoms. Second carbon atom will get double bond O now. O3. Second is zinc H2O. Now you have to understand it also. 1, 2, 3 carbon atoms. 1, 2, 3 carbon atoms. Second carbon will get double bond O. So now it is what? Ketone. Plus 1 carbon, 2 carbon, and this carbon for second carbon. That means the last carbon will get. That means it is CH3CHO. Got it, guys? Yes or no? Please tell me.
Yes, sir.
हाँ जी बेटा, ठीक है, उसी तरह देखिए fifth one. Hafsa, you are able to understand this? Yes or no?
Yes, sir.
Hafsa. O3, second, zinc H2. We'll break it like this. CH2 double bond O, that means HCHO. Okay, so this HCHO is coming from the blue part. Fine. Plus the red part I will write first of all like this. It also has a double bond, and this double bond will get what? Oxygen. All of you got this? Yes or no? Please tell me.
Yes, sir.
Now let us look at another case. Sixth one. What if you have a double bond inside a ring? Okay, so this is double bond here. Now, obviously, you are going to break it. So double bond will be broken and you will get 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon chain. First is O3, second is ZnH2O. Now, I will first of all make 5 carbon atoms like this. 1, 2, 3, 4, and 5. Now the first carbon atom, it is also having double bond. The fifth carbon atom is also having double bond. Both of them are having oxygen and oxygen, right? All of you got this? Yes or no? Please tell me. 1, 2, 3, 4, and 5. First carbon had double bond. Oh, I have written double bond. Fifth carbon had double bond. Oh, I have written double bond. And at the end, if you have double bond though, oh, that means it is obviously what? Or you can write it like this. 1, 2, 3, 4, 5. This is CHO and this is also CHO. Yes or no, guys? Same things. Tell me, yes or no?
Yes, sir.
Let us look at another case. 7. Let me end with the pentane structure. Let me make 6 carbon atoms. I have like this, and I have a CS3 group here also. First is O3, second is zinc and H2. Same thing, you will break it. Now you count the number of carbon atoms: 1, 2, 3, 4, 5, 6, and 7. 7 carbon atoms: 1, 2, 3, 4, 5, 6, and 7. Now, first carbon CS3, second carbon having a double bond. That means it will be double bond O. Third carbon nothing, fourth carbon nothing, fifth nothing, sixth nothing, seventh carbon is having double bond. This will be obviously CH. So write hydrogen here. Now, so last wala kya? Seventh wala carbon kya ho jayega? It will be CHO. So you can write it CHO like this. Now, important thing is that to understand this right now, but please redo all of these things. Okay. Redo all of these things in your home. Got it, guys? यहाँ पे देख लीजिए सेवेंथ वाला 1, 2, 3, 4, 5, 6 and 7 carbon atoms. Okay. Done, guys? Yes or no, please?
Yes, sir.
So that's it for today. Please revise all the method of preparation that we did, especially from hydrocarbons. Okay, especially from the hydrocarbons that we did. Now, please revise them. Both of them are very crucial. Both of them are very crucial. Okay. Try to read the notes. This you have already done. So you don't need to read these things, but rather just try to solve these problems once again. The same problems. Okay. Okay. You need to do, just rewrite these problems and do it once again. Similarly, try to understand the complete hydration of alkynes, tautomerism, and the addition of H2 where it is happening, where it is not happening. And then try to do the product and do a lot of work. Don't think anything. Whatever you are thinking, try to put it in words while you are doing the problems. Okay. So in that way, the method of doing the algorithm, first you do this, then you do this, first you check this, then you check this, then add here, then that there. Or if you write all of these things down, then it will be stuck in your head for a longer time. But important thing to note down